Bright Duty. Every student matters.
Now let's move on to certain question answers. So the first question is, name two metals which are found in free state. So any metal which is of extremely low reactivity only will be found in free state, and that is why the answer here is gold and silver. And platinum also is found in free state. Why is sodium kept immersed in kerosene oil? So sodium is kept immersed in kerosene oil because sodium reacts with oxygen to form oxide, and this reaction is highly exothermic. It releases a lot of heat. So sodium will quickly burn in the presence of air or in presence of water, and that is why to protect it is kept dipped in a kerosene solution. Which of the following is suitable for preventing an iron frying pan from rusting? Applying grease, applying paint, applying a coating of zinc, or all the above. Now, if you're using a frying pan, it means it has to go through a lot of friction, and it also has to go through heating. So if you apply paint on heating will enter the food and it will contaminate the food, so it's not a healthy choice. If you apply grease on the constant washing and all that, grease will be lost, so the layer will be removed, and also it will enter the food also, so that's also not a thing that we want. But applying a layer of zinc, which is galvanization, is a suitable option, because then the layer of zinc is neither affected by heat nor by washing, and it will remain. So that is why the answer is C, applying a coating of zinc. You are given a hammer, a battery, a bulb, wires, and a switch. How could you use them to distinguish between samples of metals and non-metals? So we studied the physical properties, and we know that metals are malleable and ductile, whereas non-metals are not. So first we'll use hammers for these property. If we beat anything with a hammer and it turns into a sheet, or it doesn't break but gets lighter, like it gets flatter, then that thing is a metal. Whereas something which breaks on immediately applying force is a non-metal. The second thing that we can use is we can use these things to create a setup. So we join a battery, we attach a switch, and then we attach a bulb. We leave a space here for attaching the sample. So here we will attach the sample. So if the bulb lights up, then we know that it is a conductor of electricity. If this thing here is lighting up the bulb, then it means it is a conductor of electricity, and metals are the conductor of electricity, non-metals are not. So anything that is lighting up the bulb, that is completing the circuit, would be a metal, whereas anything that is not would be a non-metal. There are exceptions here, but they would likely not be provided in this scenario, so we can ignore them. Assess the usefulness of these tests in distinguishing metals and non-metals. So here we are doing this test based on two physical properties. First, we are using the hardness, or you can also say it is the ductility or the malleability basically, which is entirely opposite in metals and non-metals. So non-metals are not hard, they are brittle and soft, whereas metals are hard and malleable. So this is an easy way to know by using the hammer. The second is based on conduction of electricity. So anything that is not conducting electricity is likely a non-metal, and anything that is conducting electricity will be a metal, because all metals conduct electricity. So these are the properties based on which we have devised these ways. Of course, there are certain limitations. For example, for hardness and malleability, sodium and potassium would be a limitation. If we used it on them, it would not give us the desired results because they are soft and brittle. Whereas for conduction, the limitation would be graphite. So graphite is a non-metal which will conduct electricity, but it is actually a non-metal. So there are certain cases where this test might not work, but otherwise it works throughout. What are amphoteric oxides? Give two examples. So amphoteric oxides are those which react both as basic substances and as acidic substances. Two examples would be aluminium oxide and zinc oxide. So aluminium oxide and zinc oxide react both with acids and base and behave themselves as base and acid respectively in different situations, and that is why they're called as amphoteric oxides. Most metallic oxides are actually basic in nature, but not these. Name two metals which will displace hydrogen from dilute acid, or two metals which will not. Now you might be surprised to see hydrogen here, but if you go back to the reactivity series, let's just go back to the reactivity series. Yeah. So here you can see that actually hydrogen, which is a non-metal, is also included. Hydrogen has only one electron, that is why it is very difficult to group it in either of the places. But hydrogen is part of the reactivity series, and anything that is below it, so copper and mercury, silver and gold, all four will not be able to displace hydrogen, whereas anything from up here will be able to displace hydrogen from its compound. So two metals which will be able to displace hydrogen will be sodium and potassium. There are multiple options, you can write any of them, there's no wrong answer. Which will not be able to will probably be silver, gold, copper. There are many options in either of the two, and you can mention any of them. What is a Thermit reaction? So Thermit reaction is when it is a process of extraction of ores, but it is also used in joining of the tracks of a railway track. To do that, we need a lot of energy, and to release this energy, aluminium is reacted with iron oxide. So iron gets free, aluminium oxide is formed, and a large amount of heat is produced, which can actually put together, join the two railway tracks. So this is also a process of extraction of iron. So if it was extraction of iron from its ore, we would use this process, but we can also use it in other places where a lot of energy is required, because it is a highly exothermic reaction. Pratyush took sulfur powder on a spatula and heated it. He collected it. So let's just draw a system here. So there's a spatula which has sulfur powder on it. He collected the gas evolved in a test tube by keeping it over it, and now he wants to see if what will be the action on the glass. So will it be on the dry litmus paper and the moist litmus paper? So as we have studied before, that a dry litmus paper will not show any action because it doesn't have any ions. So since no ions are being formed, there will be simply the dry litmus paper will not show any change, even if it was blue or red, because of the feature of dryness. It is unable to ionize, and the litmus paper catches the H plus ions which are not present here. Now what will be shown in a moist litmus paper? Firstly, let's see sulfur. So sulfur is heated in the air, that means in presence of oxygen. So it is likely forming one of the oxides. We know that the oxides of metals are basic, and the oxides of non-metals on the other hand are acidic in nature. So because it is an acidic oxide, when a red litmus paper is brought near it, which is moist, then the red litmus paper will turn blue. Sorry, when a blue litmus paper is brought near it, then it will turn red. So we use a blue litmus paper and it turns red. It shows that it is acidic in nature. So any oxide of non-metal will be acidic in nature, and that can be seen by bringing a moist litmus paper near it. Why does the dry litmus paper not show this reaction? Because the ions are not being formed in the dry state, and that is why it cannot capture the ions. Give reason why platinum, gold and silver are used to make jewelry. So we use platinum, silver and gold for many reasons. Firstly, because they are malleable and ductile, so they can be changed into any shape. They're also less reactive, so they will not corrode. And they're also lustrous, that is why they will be shiny and beautiful to look at. These are the three reasons why we use these elements for making jewelry. The second question is, give reason why aluminium is highly reactive metal yet it is used to make utensils for cooking. So we have already studied this before. We can use a process of that on the aluminium a layer of oxide is deposited which prevents further oxidation, which is resistant to heat, cooking, washing, and that is why it can easily be used in cooking processes. And also because it is malleable, it can be made into any shape of a cooker or a kadhai or any other utensil. Carbonate sulfide ores are usually converted into oxides during the process of extraction. So why are these converted into oxides? First, because it is very easy to reduce an oxide, but to obtain metal directly from carbonate and sulfide is not an economical process, and that is why the first change to oxide, from which they can easily be reduced by using either coke carbon or displacing it by a highly reactive metal. You must have seen tarnished copper vessels being cleaned with lemon and tamarind juice. Explain why these sour substances are effective in cleaning these vessels. So what is the tarnished copper is? It is CuCO3. Right? We have studied this before, that copper gets tarnished by a green deposit of copper carbonate. Now to it we are adding any form of acid. Basically lemon juice and tamarind juice are both acids. When we add acid to this base, so you know that the salts of metals are basic in nature, so you add the base and acid and it gets neutralized to form salt and water, and the salt and water will be washed off. So we are removing the deposits of these basic oxides or carbonates on the metals by reducing them with acidic substances, by applying acidic substances, which will finally lead to the removal of the metal by a neutralization reaction. So that is all for this chapter. We have studied the physical chemical properties of the metals and non-metals. We studied how to extract metals from their ores. We studied corrosion and ways to prevent it, and then we studied different exercises based on it. Hello students, now let's exercise for the final portion of this chapter. Now the first question we have here is that metallic oxides of zinc, magnesium and copper were heated in the following metals, in which case would displacement reaction take place. So we have zinc oxide, magnesium oxide and copper oxide reacting with zinc, magnesium and copper. Now for the answer, you see that zinc oxide and zinc will not show a reaction. So that is obviously there's a no reaction here. Again, the same goes for magnesium oxide and magnesium, there would be no reaction, and for copper oxide and copper. The same element will not be able to displace, and even if it does, it doesn't make any sense. But for the others, we have to remember the reactivity series. Now magnesium oxide reacts with zinc. Now zinc is more reactive, magnesium is more reactive than zinc. So magnesium being more reactive, zinc will not be able to displace it, and that is why no reaction would occur. But the copper oxide and zinc displacement would occur because zinc is more reactive than copper in the reactivity series, and that is why displacement would occur. Now that we move on to magnesium, so magnesium and zinc oxide, we know that magnesium is more reactive than zinc, and that is why a displacement would occur. Magnesium would displace zinc from its oxide. We have magnesium and copper oxide. Again, magnesium is much more reactive than copper, and that is why it would easily be able to displace copper from its oxide. Now copper on reaction with zinc. So copper is not more reactive than zinc or magnesium, and that is why it will not show any reaction here. So the entire purpose is that you remember the reactivity series. We know that magnesium is at the top, then there is zinc, and then there is copper. So based on this arrangement, we can easily solve such questions. We just have to keep in mind the reactivity series. Which metals do not corrode easily? So for corrosion, a metal has to react with atmospheric substances like air, like water, or like different gases present in the air. For it to show a reaction, it has to be reactive, right? So based on this principle, anything which is lower down in the reactivity series will not corrode easily. So the elements like gold and platinum do not corrode easily because of their low reactivity. The next question is, what are alloys? So as we've already studied, that alloys are homogeneous mixtures of two or more metals and it is metals or non-metals, and it is done in a particular proportion. So it is a homogeneous mixture of two or more metals or non-metals, but a metal has to be present in it, and then it is called as alloy. So the example of alloy can be steel, example of alloy can be brass, etc. So there are different types of alloys, and I've already discussed the composition of various alloys, but the definition is a homogeneous mixture of a metal with other metals or with non-metals. Which of the following methods is suitable for preventing iron frying pan from rusting? Now it's a frying pan, so it has to be used for cooking, and it also has to be cleaned and washed regularly. Keeping this in mind, let's see the options. Applying grease. Now if we apply grease, first of all, it would come in the food, and the taste of the food would be spoiled, and it will not be fit for consumption. And second of all, when we wash it, the grease would be removed, because grease is washable. So that is because of these two reasons we cannot use grease. If we apply paint on heating can lead to fumes and can lead to poisonous substances being formed, which would be unhealthy. That is why we cannot apply paint. Again, because two options are wrong, all the above would also be wrong. The remaining option is applying a coating of zinc. So when we apply a coating of zinc, then the iron is prevented from rusting, and also it can be washed and food can be cooked in it, and there won't be any problem. So the answer is C, applying a coating of zinc. The next question is, state two ways to prevent iron from rusting. And there are many ways that we have discussed. One of them is galvanization, applying a coating of zinc to prevent rusting. One is painting, simply cutting off the contact with air and moisture. Alloying, making alloys, we've already discussed that. And greasing, again cutting off the contact with air and moisture. So if you want to mention any of these, I would suggest painting and greasing be considered as one category, galvanization and alloying as other. So there are 1 point, this is the second point, and that would be your third point. So you can name any of these. You must have seen tarnished copper vessels being cleaned with lemon juice or tamarind juice. Explain why these sour substances are effective in cleaning the vessels. Now that you have studied properties of metals, you know that metals react to form oxides which are basic in nature. So when there's a basic substance present and there's an acidic substance that you apply on it, when you rub these two together, a neutralization reaction would take place, a salt would be formed which can be washed off. So when the corrosion happens, all the compounds of the metal which are formed on the surface are basic in nature. When you applied acidic substance like lemon or tamarind on it, it removes the basic layer by neutralizing it and forming a salt which can easily be washed off with water. And that is how the metal is cleaned, the metal of copper. The next question says, give reason for why platinum and gold and silver are used to make jewelry. Now there are two reasons for why these elements particularly are used to make jewelry. The first is they are malleable and ductile. Because they are malleable and ductile, they can be shaped into wires, they can be made into intricate designs, and that will give a variety of options for the jewelry to work on. But the second and more important aspect is that they are lustrous, because they are so bright and shiny that they look good when made into jewelry. They're not dull, and that is why they give the shine which is required in jewelry. So because of its luster and because of its malleability and ductility, they are used to make jewelry. Sodium, potassium and lithium are stored under oil. So sodium, potassium and lithium are stored under oil because they are highly reactive metals. These metals are so reactive that even on coming in contact with air or water, they burn vigorously. Sometimes they catch fire when coming in contact with water. So that is why they have to be stored in a condition which is inert, where there is no interaction with elements with which they could interact, and that is why they are stored dipped in kerosene oil. The next part is aluminium is a highly reactive metal, yet it is used to make utensils for cooking. So what happens is that aluminium forms a thin layer of oxide on its surface, which prevents the oxidation of the metal further. And because of this property, it can be used to make even bodies of ships, bodies of aircrafts, and also utensils. because of this property, and also because of the property that it is extremely malleable and ductile. So there are two reasons: malleability and ductility, and the property that it does not because of its layer of formation of oxide, it does not go corrode further. The next part is carbonate and sulfide ores usually are converted into oxide during the process of extraction. So carbonate and sulfide ore are usually converted to oxide during the process of extraction because it is easy to reduce oxides into metal as compared to carbonates and sulfides. Now I do understand that this is a topic of which will come further in the chapter, but because it is asked with this question, let me just explain to you briefly that it is very easy to extract a metal from its oxide form in the ore, but it is not so easy to do it from a carbonate or a sulfide form. And because of this reason, all these elements are reduced to to oxide form, and then metal can be extracted from them. Are coated with tin, not zinc, because zinc is costlier than tin. That is not relevant here. Zinc has more melting point than tin. Again, not relevant. Zinc is more reactive than tin, and zinc is less reactive than tin. So the answer is zinc is more reactive than tin. Zinc is a highly reactive metal, and because of which it could react with the food kept inside the container, and the food could go sour. So if there's an acidic substance like tomato or tamarind or lemon juice inside the food, it would react with the metal, and displacement would occur, and it would the food would go bad and it would not be fit for consumption. And that is why zinc is not used to make these cans.